In this concept video, we're going to be discussing the empirical rule, or the rule of three standard deviations. Let's read through each one of these statements, then we're actually going to draw this on the normal model, the bell-shaped curve, which is pictured below. Almost all the observations in any data set lie within three standard deviations to either side of the mean. Also, a data set that varies a lot will have a large standard deviation, and three standard deviations from the mean will be pretty extensive. A data set that varies very little will have a small standard deviation. So three standard deviations from the mean will be narrow or close to the mean. If the distribution of the data is bell-shaped, the empirical rule says 99.7% of our observations are within three standard deviations. Let's fill in some information here, and I'm going to give you a few symbols. This is the lowercase Greek letter m or mu, and that means the mean. So I'm going to write that here. And then standard deviation is a lowercase Greek letter s. So I'll write standard deviation here. We learned how to calculate that in the past lesson, in the last lesson. So if I move from the mean to the right by one standard deviation, I'm going to have the mean plus one standard deviation as my first line. If I go to the left from the mean by one standard deviation, I'll have the mean minus one standard deviation. Now you might be wondering how much percent of the data is between those two. So let's go ahead and we'll do a different color here. We'll draw a vertical line up and then here. And what we're actually wondering about is how much of the data fits in between that bell-shaped curve and then the axis below, the horizontal axis. So the percent of data that fits there is 68%. Also, one thing that you want to know here about the normal model is that if we look at the middle, which is right here, the mean's always in the middle, half the data will lie to the left of the mean and half the data will lie to the right, like this bell-shaped curve here is symmetric. If that's the case, we can even break this down even further, and we could say that 34% of the data is between the mean and one standard deviation to the right, and 34% of the data is between the mean and one standard deviation to the left. That totals up to be 68%. Let's keep going with a few other items here. We'll do the mean plus two standard deviations. So there's your first one. There's your second one. So that's the mean plus two standard deviations to the right. And then we'll do the mean minus two standard deviations, or two standard deviations to the left. And that's right here. We're going to fill in that information as well. And so if we were to draw a vertical line here, and here, we're wondering how much data fits between there. And the answer to that is 95%. 95% fits in between here and here. Now, if that's the case, if I took 95 and divided it by 2, that gives me 47.5. And if I want to know what this little piece is right here, just from like here to here, what would that be? Well, that's going to be 47.5 then minus 34. And so I get 13.5% there. And then this little piece right here is going to be 13.5%. And if you added everything that we've done in red so far up, so if you do 13.5, 34, 34, and 13.5, you're going to wind up with 95. So there's a couple different ways you can think about it. You can think about the empirical rule as each individual section in red, or you can also think about the empirical rule as being one standard deviation above to one below, 68%, two above to two below, 95%. And we just mentioned before that we're actually going to want to check out three standard deviations to the right. So now there's not a lot of data. The height, by the way, this is kind of like a histogram. The height, by the way, corresponds to how much data there is. So you can see here that the height of the curve is very close to the horizontal axis. So there's not a lot of data right there. But if we think about it, if we think about all the data from 3 standard deviations to the right and 3 to the left, that's almost 100%. Almost all of the data is between those two values. It's actually 99.7. So if you did from here to here, I'm going to draw this below, I think, a little bit. That's going to be 99.7. Let me erase that. So we'll go 99.7% of the data, almost all of it, fits between 3 standard deviations to the left and 3 standard deviations to the right of the mean. We also want to label the little pieces over here. So what I'm going to do to label those little pieces between 2 and 3, so that would be like right here. How much data is in there? Well, it's not a lot, but it's got to be something, right? There's some area there. You can also think about the amount of data as being the area between the curve and that horizontal axis. So I'm going to take 99.7 divided by 2. That's going to give us the half of the data that fits to the right of the mean, up to 3 standard deviations to the right. And then I'm just going to subtract 34 and subtract 13.5, and I get 2.35%. And that's going to be the same. This normal model is symmetric for both the left and the right-hand side. And once again, that would be the data between here and here, or between here and here. So not a lot of it, but a little bit. And if you added up every single item we've done in red, you should get 99.7%. You could keep going, but it gets a little crazy, right? Like you wouldn't even hardly be able to tell where the curve was if we kept going to 4 standard deviations to the right and 4 to the left. So we just kind of end it right here. We say, all right, 68% of the data is between 1 to the right, 1 standard deviation to the right, and 1 to the left of the mean. 2 standard deviations to the right of the mean and 2 standard deviations to the left, you've got 95%. And then between 3 standard deviations to the left and 3 to the right of the mean, you've got 99.7%.